Yes, we want to dive in. We want to see to managing tables, manipulating data by using data manipulation language statements, then manipulating XML data. Now, data integrity. Normally, data integrity
Okay.
is about ensuring that the data that will go into our the database is a sane
Okay.
data.
Exactly.
Is a data that does not contain unnecessary or needed parts. That it only contain
Okay.
needed part, and the data that we enter is going to be valid. That is
Alright.
what, for instance, now, if you are entering data for youth copper, now
Okay.
people that should be able to serve should not be more than 30. So in order to
All
make
right.
sure the table that is going to contain the data for such system is sane, we
Okay.
need to ensure, we need to put something on the database such that any age that is more than 30 will be rejected. So that is what we call data integrity. So data integrity is
Integrity.
enforced. We enforce this in order to ensure that the data in our database is accurate, consistent, and reliable. So
Like, okay.
there are different ways of enforcing data integrity, and that is why we have different classes of data integrity. We have entity integrity, domain integrity,
Domain
referential
referential.
and user-defined integrity.
All
Now,
right.
the different types of integrity have to do with, as it's even explanatory. Now, entity integrity has to do with the integrity of the actual data. Normally when
Okay.
we are dealing with relational data and entity relational mapping,
Management.
we did mention that any individual or any item
Mm-hmm.
that we are trying to collect data about is sufficient to make a table. So that is the entity. So the individual forms a row. So the entity integrity has to do with ensuring that the row of our data is going to be valid. Normally, when you are
Okay.
collecting information about the name, the age, the sex, and the like, it's not that
Okay.
someone will now supply the age. We supply the name, and we leave address out. We not supply address. Such data is
Okay.
not valid. So we make sure
Okay.
we ensure all the necessary parts are entered. Domain integrity
Okay.
also deals with the domain. Then referential integrity also is about how to be able to refer to other table. The user-defined integrity. Sometimes, okay, that like the example I cited about
Cover
yes,
data.
I use service. Now, that's a user-defined data
Okay.
integrity. So by the time we
Uh,
specify that age must be less
Can
than or
I?
equal to less than 30, that is user data integrity.
Yes, what the?
Now,
Can I
user
quickly ask a question? Can I quickly ask a question before we proceed?
okay.
Okay, so talking about inputting, let's say for instance, the example you just cited that data for copper, how does that works on application? If an application is developed, if an
Actually,
application is developed,
and
so how do we
the
input
way
such
it
data?
works,
Eh?
is such that we are going to build the necessary form in our
Okay,
application to collect the necessary pieces of information. Then after
okay,
collecting the information, there should be a way to trigger an action that will submit such data into our database, and that is by including submit data or store data button in our form. So once that data button is clicked, then at the back end, we are going to now process the data supplied. We are going to do what we call validation to ensure that all the data entered are valid. Then once we have ensured that, then we proceed to storing such information in our database. So when creating tables, SQL allows us to maintain integrity. There are different ways by which we can maintain this integrity. We can apply constraints. By the time we get to it, you are going to know what we call constraints. Constraints are the necessary, like a necessary measure that we are putting in place for the people interacting with our database to comply with. Their inability to comply with such constraints, we make sure their data is not submitted to the database. But if they comply, their data will be submitted to the database. Now, enabling and disabling constraints. We can apply constraints, we can enable it when we need it. When we don't need it, probably at a short time, we don't need it, we disable it. When we need it again, we re-enable it. Then we apply rules. Then we use user-defined types. All this we are going to be covering later. Now, constraints. What are constraints? They are rules that must be followed to maintain consistency and correctness of the database, of the data. You know, as I said it earlier. Now, syntax of a constraint is when we are creating our table. When we are creating our table, we specify the constraint along with the column. You know, normally, after mentioning the text that we use to represent the column, we also specify the type of data that such column must take. Then we can specify the constraint too. The different constraints that we have, yes, you are going to now get it. The different constraints that we have primary key constraints. If you specify that a particular column is having is a primary key, then such column is having primary key constraint. Sometimes you make sure that the data that you want to collect must be unique for every row of information in your data. Then you specify unique constraint. When you say data must be unique, that is unique constraint. Sometimes you specify a particular column as a foreign key to another column. That is foreign key constraint. Then sometimes you want to check a particular column. You want to take the value they want to supply for it. You want to check it against a particular condition. That is check constraint. For instance, the example I mentioned regarding the NYSC thing, the youth corper thing, is good. We are going to make use of check constraint. Before you submit the data to the database, ensure that the age is less than 30 years.
30. Just this for example.
Yes. Default constraint is also available. Now, a check. Which one of the following options can be used to specify the check constraint? Now, when you are checking value, there are different things that you can use to check. Now, what you can use to check, if you reason with what you have done before now, you know, we can use like. When you are checking against similar value, like you remember when we did mention as a percentage.
Then I remember.
Underscore. So at that instance, we are using like for instance now, if you say like, if you say like percentage,
I'm listening.
Pot, for instance, pot.
Okay. Percentage pot.
Then another percentage.
Okay.
What this means is any value that include pot in the middle, it may have something before it, it may have something after it. So this is going to capture the pot.
Okay.
Port Harcourt. In as much as you have 0 to anything or nothing before the pot, it will capture it. In as much as you have anything or nothing after the pot, it's going to capture it. So that is how like work. Then in, when you want to mention a list of value, you now want to check any of those lists. Any of those lists, you use in. Then between, when you want to check for the value between a range. So like, in, and between. Like, in, and between. That's the correct answer. Now, another check. Which one of the following types of data integrity ensures that only a valid range of value is stored in a column?
That should be user-defined integrity.
Which of the following types of data integrity ensures that only a valid range of values is stored in a column?
That should be I'm choosing domain integrity.
Domain integrity is the right one.
Let me check. Okay,
it's the right one. Domain integrity is the right one.
Yes.
Now, another check. Which one of the following constraints
enforces domain integrity?
Enforces domain integrity by restricting the values to be inserted in a column.
That should be default.
By restricting the values to be inserted in a column.
I'm picking default.
Are you sure?
Yes.
It's something I've mentioned before. It's something I've mentioned before.
Okay, let me check. Well, let me try and recollect. Which of the following constraints enforces domain integrity by restricting the values to be inserted? That restrict it. Okay, that should be checked.
That should be checked. Check is the answer.
Check.
So,
check answer.
Now, rules. Rules help us in enforcing domain integrity for columns or user-defined data types.
Okay.
Then it can be applied before an insert or update statement is issued. They are used to implement business-related
restrictions.
Business-related restrictions or limitations. Now, we create rule. This is how to create rule. We use create rule, then we mention the rule name as, then we put the conditional expression that is going to be the basis for the rule. Something like this. Now, after we have created our rule, we need to activate the rule by using stored procedure SP_bind rule. So we bind the rule.
Okay. How do we bind the rule?
This is an example now. You have created a rule called rule type. So You
Root
use
type. Okay.
SP underscore bind rule, the name of the rule. Then you are binding it to this column. You know, this is
now what I do not.
This is an employee
What?
leave table, and it has this leave type as the column.
Okay, sorry, but what I do not understand is what I want to get right is those rules. Are those rules need to be stated? Do we need to? Are we going to state all those rules that we want to bind? The rules that will be banded. Are
Yes,
we going to be?
the first thing we have to do is to first create our rule.
Okay. That is the existing rule, Abi.
So it is an existing rule that we are binding here.
Okay.
By the time we are going to do the hands-on, you are going to see how we create our rules.
Okay.
Now, user-defined data types. You know, we have normal primary data type that accompany the application, but we can also specify our own data type in a way that we like. So they are custom data type defined by the user with a custom name. They can be created by using create type. We use create type to create them. This is an example. Create type, the name of the type is DSCRP, a short form for description. Now, it should be a variable character of length 100, but must not take a null. So when you are defining a particular column as this data type, you don't need to specify another constraint, because as part of this data type, you have included a constraint, not null. That is, it shouldn't take an empty value. It should always contain a value.
Okay.
You understand?
Yes.
Is it sufficient that we stop here so that we continue from creating synonyms the next time?